Hi, Lucas.
Hello.
Hi, Allison. Obviously, we're going to give some people another 30 to 60 seconds here. I'll just go ahead and present my screen. Lucas, Allison, Jack. Lucas, Allison, Jack. Jack, are you back from the Philippines or whatever?
Yeah, I got back last night.
How late?
That's like 9 p.m.
It's not so bad. Was there any issues with your flights? Any delays or frustrating stuff like that?
Nope.
Jonathan, hello. Connor. Okay. All right, well, here I go, Aaron. Let's do this. Aaron, can you see my paper on my? Hold on, 1 second. Yeah, now, Aaron, just to make sure you can see my paper, right?
Yeah.
Okay. All right, gang. Let's dive right in. Okay. So we're getting into like the last sort of. I don't know. I don't want to say it's like all downhill from here, but we're gonna kind of try to wrap up this chapter. Before we take a test with some very important, like fundamental properties of exponents. Okay. I was seeing some semi-concerning stuff on like that one quiz. So, I mean, but I'll talk about that here in a second because look, so this right here, this is like a 2.4 flashback. 2.4, huh? 2.4 maybe. Was it 2.4? Probably. But x to the third times x to the fourth. What do we do with the exponents and why? Jack, do you know? What do we do with x to the third times x to the fourth?
You add the exponents.
You add the exponents. We add the exponents or add the powers. Why do we do that? I don't know if we ever wrote this all out, but I mean, x to the third power literally means like x times x times x. That's literally x to the third power. And then x to the fourth power is x times x times x times x. When you think about all of this together, that's now just x to the seventh. So that's at least a decent explanation why we can just add the powers, because if you wrote it all out like that, that's what you would have. You would just have x to the 7th power. So yes, in this exact situation, the shortcut is just to add the powers. Now, I also want to do, like I was referring to a minute ago, I also want to do an extra flashback to some other stuff earlier in this sort of chapter. Compare that to versus x to the 3rd plus x to the 4th. Connor, what can you tell me about x to the 3rd plus x to the 4th? I should also see if anyone else has jumped in here. What do you think, Connor? X to the 3rd plus x to the 4th. Can we do anything with that?
Not to my knowledge, no.
Yeah, no. And so I just wanted to kind of, because I was seeing this sort of kind of thing on the quiz with a few people, like, so maybe like another example, okay, like 2x and 4x squared. Like if these were two terms, you could totally multiply these together. These will multiply together. 2x times 4x to the 2nd power. They will multiply together and actually like simplify. But as far as adding these together, they wouldn't add together because they're not like terms. That is a big time difference. That you have to be able to differentiate between adding these two terms together versus multiplying them together. You have to know all about that. You know what I mean? But yeah, anyway. So what we're going to move on to here is kind of like this, So x to the 2nd to the 3rd power. What does this mean? Well, I mean, what it sort of means is like, you could think of this as, if you're raising this to the 3rd power, this is what it technically means. And so wouldn't the final answer end up being x to the 6th? But I don't know, like Jonathan, is there a shortcut here, Jonathan? Like the fact that we wrote this all out and all we ended up getting was like x to the 6th, because isn't this like x times x times x times x times x times x? Final answer was just x to the 6th. Is there a shortcut there, Jonathan, that you know of?
I don't know.
Does anybody? Jack, do you know?
No.
Well, look at this. X to the 2nd power to the 3rd power. 2 and 3. The shortcut is to multiply them. Okay, so that's, again, hopefully you're kind of, focused on these big ideas. This big idea is that when you have a power raised to another power, you can multiply the powers. So here again, and you got to be able to compare that to this situation versus this situation. They're different, So when you're raising a power to a power, you can just multiply the powers together. And this is sort of why that shortcut works. Because if you just like expanded it all out. So this basic example, Lucas, what would this be? M to the 5th to the 2nd.
M to the 10th.
Perfect. Did someone else just tune in? Just want to, maybe not. Okay. Yeah, nice job, Lucas. Now again, I don't want to keep over explaining this, but if you compare that to versus m to the 5th power times m to the 2nd power, this is different. This, look, this is when you would add the powers. This, Lucas got correct, is when you would multiply. Here, this example, you're raising that 4 to the third power, but I mean, you're also raising 2 to the third power. People forget about the 2, so don't just say x to the 12th, and don't even just say 2x to the 12th. You have to remember that that third power also hits the 2. So, 2 to the third power, well, you could just say that's 8, literally 2 times 2 times 2, but whatever. I'm not going to be super, super, super strict in that manner. Just like 2 to the third, and then when you do x to the 4th to the third, that's x to the 12th. Likewise here, that third power is going to hit the 3, so that's just 3 to the third. In a way, how about this? In a way, what power, Aaron, technically, it's invisible, but 3 has a power. What is that power?
0.
Nah, try again.
1.
1. 3 is literally 3 to the first power. So if you want, and again, it's not 5. This 5th power only is with the x, not the 3. You know what I mean? So this is technically 3 to the first. So if you wanted to approach it like, well, it's 3 to the first power to the third power, and you could like multiply those powers, you could also look at it like that. But then we have x to the 5th to the third. You're going to multiply those powers. And then you have y to the second power to the third power. You can multiply those powers. And it's probably okay that you stop there. The only thing you could possibly do is like, well, 3 to the third power, that's going to be 27 when you do 3 times 3 times 3. But whatever. That's not really what I care most about right now. Ooh. I wonder if this looks scary to anybody. I hope it doesn't. It's just going to take like multiple steps, okay? So what I would do is deal with that, and I would deal with this, and then see what happens, because I have this 2x cubed y that needs to be raised to that power, and then I have this 5x squared y to the 6th that needs to be raised to that power. So step 1, 2 to the 4th, x to the what? X to the 3rd to the 4th. That should be x to the 12th, because again, when you're doing power to a power, you multiply the powers. And then you have y to the 4th, or in other words, y to the 1st to the 4th, and that's just going to be y to the 4th, okay? So that takes care of that. Now let's raise all of this to the second power. So 5 to the 2nd, because that's just a 5, or 5 to the 1st, if you want to go that route. X to the what? X to the 2nd to the 2nd, x to the 4th, and then y to the what? Y to the 6th to the 2nd. That's going to be y to the 12th. Ooh, okay. So now what do we do? Jack, any thoughts?
You add the like terms?
Yeah, we're gonna. Well, I got to criticize you a little bit. I mean, you're. I'm not saying like you're wrong, but I mean like, you wouldn't like x to the 12th and x to the 4th. You technically wouldn't call those like terms, but I think you know that. You were just trying to explain it the best you could. But yeah, you could take x to the 12th times x to the 4th and add the powers. See, now we're all of a sudden in a situation where we're going to be like simplifying with adding powers. So x to the 16th and then y to the 4th times y to the 12th. Again, they're not like terms, but that's okay. We can still multiply them together by adding the powers. And I guess now, again, let's not let ourselves be confused by like, what the heck is 2 to the 4th times 5 squared? This is really, really, really just, I think, 16. and this is really, really, really just like 25. So I guess we could like do that. I mean, but I wouldn't really care if you just left it as like, because these don't exactly simplify together because these bases don't match. But anyway, so 2 to this, let's see, what is 16 times 25? We might as well do it because that looks a little ugly. So like 16, I got my calculator now. 16 times 25 is 400. So that's probably the best answer. Just making that into a 400. Try this one on your own for a second. Go. Start that one on your own. Give it a quick try. Don't let that negative cause you too much grief. I mean, yeah, we're technically raising -2 to the third power, not just the 2, but it's a -2 technically. So, that's important to recognize. And then sort of the same thing over here. Like when you eventually do like this number to the second power, it's technically a -4, not just a 4, okay? So I hope you're getting x to the 9th, y to the 3rd, and then again, like technically that's an entire -4, not just the 4. And then this should be x to the 2nd, y to the 10th. Okay? Connor, the final, when it comes to like the x and the y in your final answer, do you have that, or?
X to the 11th and Y to the 10th. Oh, 13th, sorry.
13th. Yeah, so x to the 9th, there you go. Because again, we went from here having to multiply powers, but now we're in an adding powers situation. And then as far as the numbers go, don't let the numbers mix you up. Again, these are not the same base, so you cannot say, oh, something to the 5th power. No. The bases would have to match. So what this technically is -8. -2 times -2 times -2. What this technically is a positive 16. Yeah, this is -8. That's positive 16. It just is. So, I guess we would have like, again, we might as well clean this up entirely. -128. You know what I mean? So again, to summarize this 2.8 lesson, I mean, we had, this is when you add powers. This is when you multiply powers. You got to be able to kind of recognize the difference. Let's do, while I have you guys, and it's only 11:03 a.m., this was the plan anyway, let's also take care of 2.9 really quick. Okay? 2.9. So probably on the back of your paper that we were just doing. All right. So let me make sure no one else has jumped in here. Doesn't look like it. 1, 2, 3, 4, 5, 6. Okay. Warm-up questions. Oh, for crying out loud. 3 divided, that's just 1. 5 divided by 5, that's 1. Even x divided by x is 1. and y divided by y is 1. Okay, so what does this mean? Technically it means like x times x times x times x all over x times x times x. So, I mean, what happens in a way is that x over x, like this divides to basically be 1. This divides. This divides. Another classic word that math teachers throw around now is cancel. Like these two x's cancel, these two x's cancel, these two x's cancel. What they're really doing is they're dividing out to be 1. So what's left after the canceling, after the dividing? What's left is x squared. Okay? Aaron, do you smell a shortcut here from this different situation with powers? Do you kind of smell a shortcut?
5 minus 3.
Minus! So there we go. X to the m power, to whatever, x to the whatever power over x to the whatever power. You can just subtract the powers. That's shortcut number 3. So again, you got to be able to differentiate between, this situation and, this is when we add powers. This, how this looks, this is how when you multiply powers. But when you have like a fraction or a division, this is when you can just subtract powers. And all this canceling nonsense is a reason why this shortcut works. So, Lucas, n to the 6th power over n to the 3rd power. Again, these bases of n match. So what's the final answer?
N to the 3rd.
Perfect. And then this one, again, no calculator. 8 to the 7th over 8 to the 3rd. Again, we could do this, you know what I mean? But these bases match. If that was an 8 and that was a 6, we couldn't do anything. But having these bases both be 8, it's the same as what Lucas just did with a base of n. We could just subtract the powers, 8 to the 4th, which is something. What is it actually? 8 times 8 times 8 times 8. Not that I really care that much, but this is actually 4,096. Here, okay, let's slow down a second. It's getting a little nastier. X to the 4th power over x. Once again, Jonathan, what's the invisible power on the x? Allison, what do you think? What's the invisible power on the x? Don't know. It's 1. That's very important to understand. So in a way, this is like x to the 4th over x. You're going to have x to the 3rd because like you're technically subtracting those. But how about 6 over 3? What do we do with that? Do we subtract? No. This is not some fancy shortcut with exponents. This is just like 6 over 3. This is like literally 6 divided by 3 like you were doing back in like 2nd and 3rd grade. So that's just 2. So do not confuse 6 divided by 3, that's just division, with x to the 4th divided by x. That's where you can like subtract powers. So don't get those confused. So in the next example, 12 over 4, that's just 3. That is like 2nd or 3rd grade division. That's not any fancy shortcut. But when you do like the x to the 3rd over x to the 2nd, that is going to be like a shortcut where you subtract the powers. Okay? Now, of course, x to the 1st, that's really just x. You don't need to write that 1. And then y to the 4th over y, and again, technically there's a power there of 1, So when you do y to the fourth divided by y, you're going to end up with y to the third. Okay? The exponent subtract. You know, you could also, again, look, I'm going to like, I don't want to confuse anybody, but once again, you could think about this from the perspective of you have like 4 y's up here, y times y times y times y, and you have 1 y down here, and this y cancels with one of the 4 y's up here, and you're left with, you know, y times y times y, or, you know, 3 y's, y to the third. Okay? Ooh, uh-oh. Now look, obviously the t's, t to the 7th over t, that's going to be t to the 6th. K to the 5th over k to the 2nd. You know, Jonathan, you back on here? What? I don't know if you didn't unmute the last time or whatever, but Jonathan, do you know k to the 5th over k to the 2nd?
I'm not sure.
Well, again, this is where you would just subtract the powers. So k to this power over k to this other power. The shortcut is you can just subtract the powers. So again, like just to kind of like a quick sort of summarization, we have to learn ASAP how like this is a very big idea with a very nice shortcut of adding the powers. This is a very useful, you know, fundamental shortcut of multiplying the powers. And, you know, that's what homework is for, you know, to kind of do repetition and learn this big idea of, like, you know, being able to, how do you deal with this when you have, like, the same base and there you got powers and it's like k to the 5th power divided by k to the 2nd or over k to the 2nd. You can just subtract. Now, once again, but at the same time, we can't be confused when it's like 6, just plain old regular 6, over plain old regular 15. These aren't powers. You would not subtract 6 and 15. That's just like literally 6/15. You know, think back to 5th grade or something, or 6th grade. You would just reduce this fraction. Because, you know, I know 12 over 4, like look back here. 12 divided by 4, that was clean division. Yay. But 6 divided by 15, that's not clean division. But at least we can reduce that. So 6 over 15 would reduce as a fraction to what? Think about it for a second. 6 over 15, let me think about that. 6 over 15, would that be 2/5? I don't know why I'm so uncertain about that. So, but that's right. 2/5 times t to the 6th times k to the 3rd. Likewise over here, 4 over 8. That's not powers. That's just 4 divided by 8, or 4 over 8. Is that clean division? No, but will at least reduce to 1/2. You know? Heck, people, what if that was 4 over 7? If that was 4 over 7, the reality is we couldn't really do anything with it. Like 4 over 7, we would just have to leave as 4 over 7, you know? But if it can reduce, then we reduce. X to the 4th over x to the 2nd, that's going to be x to the 2nd. And then Aaron, how about y to the 6th over y to the 5th? How does that simplify?
Y to the 1st.
Perfect. And again, you don't even need to write, I mean, having a power of 1 like goes without saying. So I'm not even going to write the 1. But Aaron was right. It's just y, or y to the 1st. One final thing before I look at the homework with you for a minute or two. This is a perfectly okay way to write it. Like, look at this example and this example. But if you wanted to actually multiply all this together into one fraction, where would this x squared y go? Would it go like in the numerator or the denominator or both? Again, what I want to do is I want to actually multiply this together into one fraction. I mean, this is fine, having a 1/2 out in front, like a fraction here and then times this times that. But if I actually wanted to like multiply this together into like one fraction, the x squared and the y would actually go into the numerator. So 1 times, and we actually wouldn't even need to write the 1. Like, it wouldn't even be necessary, But yeah, like, this would go to the numerator. So like over here in this example, you don't have to all the time, but if you actually wanted to multiply this into like, and make this all just one final fraction, the t to the 6th and the k to the 3rd would go into the numerator if you actually want, because again, like technically it's like all over 1 in a way. So 2t to the 6th, k to the 3rd, all over 5. It's just another way to write it, Okay. Those are the notes that you're going to be turning in momentarily. But your homework, see, here's the thing. A lot of this is combined, so get out your homework really quick, like this 2.8. It's a pretty big homework assignment. It's not going to be due anytime soon as a whole. So, I don't know what I'm going to do. Well, I kind of do. But there's like 6 pages to this, right? So I don't think it'll be due until like Thursday or Friday of this week. So, but what you're going to be able to do is you're going to be able to do like page 1 and get started on that. Okay. Now remember, what do we do with these powers here? What can I call on here? Like Lucas, do you know what you can do with these powers? Like 4 to the 2nd times 4 to the 2nd?
It'd be 4 to the 4th.
Yeah. See, this is when you can add them. And again, if you want to leave it like that, that's fine. See, like this, 4 times 4 to the 2nd, this would actually be 4 to the 3rd. You know what I mean? So this first page is all about adding the powers. Now again, like number 10, don't get confused. 4 times 3, you're not going to add 4 and 3. That's just 4 times 3. So 4 times 3 is 12. But then when you do x to the 2nd times x, that is when you're adding powers. Okay? So page 1, that's like a lot of adding powers. But again, 5 times 8, that's just going to be like 2nd grade, 3rd grade multiplying. You know what I mean? So you got to know the difference between like the regular numbers and the bases with powers. And then like page 2, you should be able to get started on like immediately. And again, like heck, like this one, number 14 here, 3 over 3 to the 3rd. Again, whether the base is 3 or the base is x, it doesn't matter. This is going to be 1 minus 3. You can do the shortcut of subtracting powers and get 3 to the negative 2 power. Whoa. Okay? But then like number 18, check it out. I told you. 7 over 4, those are just regular numbers. Do they divide clean? No. Do they even reduce? No. So there's nothing to do. It's just like 7 over 4. But the k's, k to that power over k to that power, you can subtract and again actually get like a negative 1 power. So page 2 you can do. And page 3, page 3, this is where you would be doing what with the powers? Y to the negative 7 power, to the negative 8 power. This is when you could multiply the powers. -7, oh man. Got to think back to my second grade skills. -7 times -8. I believe that's... Why am I so unsure about that? Positive 56, man. Alright, so yeah, I'll assign this homework, but I mean, we still have to, there's still more to talk about. We still have to do section 210, you know? And this entire 6-page homework is not going to be due for a number of days here, but you should at least get started on it and like start chipping away. But yeah, anyway, stick around if you